For as long as humanity has looked toward the night sky, one question has echoed through every generation. Are we alone? It is a question older than modern science itself. Long before telescopes existed, ancient civilizations studied the stars and imagined worlds beyond their own. Philosophers debated the possibility of other civilizations. Writers dreamed of distant planets populated by unfamiliar forms of life. Today, that ancient question remains unanswered. Yet for the first time in history, we possess tools capable of investigating it with extraordinary precision. Among those tools stands one of humanity's greatest scientific achievements, the James Webb Space Telescope. Positioned far from Earth, Webb observes the universe with remarkable sensitivity, capturing faint light that has traveled across immense cosmic distances. Its mission extends beyond studying galaxies and stars. It also seeks to understand planets orbiting other suns. And recently, one particular world captured the attention of astronomers around the globe. Known as K2-18b, this distant planet resides approximately 120 light-years from Earth. By cosmic standards, it lies relatively nearby. Yet despite its proximity, it remains a mysterious and largely unknown world. At first, K2-18b appeared to be one among thousands of exoplanets discovered during the past few decades. But closer examination revealed something far more intriguing. Unlike Earth, K2-18b does not belong to any familiar category of planet found within our solar system. It is larger than Earth but significantly smaller than Neptune, placing it within a class astronomers call sub-Neptunes. These worlds are among the most common types of planets in our galaxy. Ironically, none exist around our own Sun. As a result, scientists have spent years attempting to understand what these planets are truly like. Do they possess solid surfaces? Are they covered by deep oceans? Do they contain thick atmospheres made primarily of hydrogen? Or do they represent an entirely new category of planetary environment? K2-18b has become one of the most important candidates for answering those questions. The planet circles a small red dwarf star. Unlike our Sun, red dwarfs are cooler and dimmer. Although K2-18b orbits much closer to its star than Earth does to the Sun, the reduced energy output of the star may allow temperatures suitable for liquid water. This places the planet within what scientists often call the habitable zone. The habitable zone is not a guarantee of life. Instead, it is a region where conditions may permit liquid water to exist if the atmosphere is favorable. Water is considered one of the most important ingredients for life because every known organism on Earth depends upon it. Naturally, any world that appears capable of supporting liquid water attracts enormous scientific interest. When Webb observed K2-18b, researchers carefully analyzed the starlight passing through the planet's atmosphere. This technique allows scientists to identify gases present in distant worlds without ever visiting them. As light passes through an atmosphere, certain wavelengths are absorbed by specific molecules. The result is a chemical fingerprint. Using this method, Webb detected evidence of water vapor. That finding alone was exciting. But it was only the beginning. Further analysis revealed signs of methane and carbon dioxide, two molecules that can provide important clues about planetary environments. Together, these gases suggested that K2-18b might possess conditions very different from those found on barren worlds. Then came the most surprising possibility of all. Researchers detected hints of another molecule, one that sparked immediate global attention. A molecule that, on Earth, is strongly associated with living organisms. The discovery was not definitive proof of life. Far from it. Yet it represented one of the most intriguing atmospheric signatures ever identified on a potentially habitable exoplanet. Suddenly, K2-18b transformed from an interesting world into one of the most closely studied planets beyond our solar system. Astronomers realized they might be looking at a place capable of teaching us something profound about the nature of life in the universe. And the deeper scientists investigated this strange world, the more fascinating its story became. The excitement surrounding K2-18b intensified when scientists began exploring what kind of world it might actually be. Traditional searches for life have focused heavily on planets that resemble Earth. Rocky surfaces, moderate temperatures, atmospheres rich in nitrogen and oxygen. But K2-18b challenges that assumption. Rather than being an Earth twin, researchers believe it could belong to a completely different category of potentially habitable worlds. Some scientists have proposed the idea of what are known as Hycean planets. The name combines two defining features, hydrogen and oceans. According to this concept, certain large planets may possess thick hydrogen-rich atmospheres surrounding vast global oceans. These environments could differ dramatically from Earth while still offering conditions suitable for life. If K2-18b belongs to this category, it may be covered by enormous oceans stretching across much of the planet. Beneath its atmosphere, liquid water could exist on a scale far beyond anything found on Earth. Such a possibility expands our understanding of where life might emerge. For decades, scientists searched for places that looked like Earth. Now they are beginning to consider worlds that operate according to entirely different environmental conditions. This shift could dramatically increase the number of potentially habitable planets in our galaxy. What makes K2-18b especially important is that its atmosphere is relatively accessible to observation. Larger planets produce stronger signals when starlight passes through their atmospheres, making them ideal targets for advanced telescopes. As a result, K2-18b has become a natural laboratory for studying planetary chemistry. The observations themselves represent one of the most remarkable achievements in modern astronomy. Scientists are not traveling to this world. They are not collecting samples. They are not sending probes. Instead, they are analyzing tiny changes in light that has traveled across trillions of kilometers of space. Every molecule leaves a subtle imprint. Every atmospheric layer contributes information. Using physics, mathematics, and sophisticated instruments, researchers can reconstruct the composition of a planet they may never directly visit. It is one of humanity's greatest demonstrations of scientific ingenuity. Yet despite the excitement, caution remains essential. Extraordinary claims require extraordinary evidence. The possible biological molecule detected in K2-18b's atmosphere has not been confirmed beyond doubt. Additional observations will be required. Scientists must carefully eliminate alternative explanations. Natural geological or chemical processes could potentially produce similar signals. Only through repeated observations and rigorous analysis can researchers determine the true source. This process may take years. Perhaps even longer. But that is how science advances. Not through assumptions but through evidence. Each observation sharpens our understanding. Each new dataset brings the picture into clearer focus. Whether K2-18b ultimately hosts life or not, its discovery has already changed astronomy. It has broadened our view of what a potentially habitable world might look like. It has encouraged researchers to explore possibilities once considered unlikely. Most importantly, it has reminded us that the universe continues to surprise us. Somewhere beyond our solar system, countless planets orbit distant stars. Many remain undiscovered. Others are waiting to reveal their secrets. Among them may exist oceans, atmospheres, ecosystems, and perhaps even forms of life unlike anything humanity has ever imagined. K2-18b represents more than a distant world. It represents possibility. A possibility that the story of life is not limited to a single planet orbiting a single star. And as future telescopes peer deeper into the galaxy, humanity moves ever closer to answering one of the greatest questions ever asked. Are we alone? For now, the universe remains silent. But with every observation, we are learning how to listen.